All right, everybody, this is Mr. Schultz again here with you. We're going to take a look at 911, but this time we're going to take a look at day 2. So we looked at day 1 last time, and the point of day 1 was we just went through and we collected some data. But let's take a look at this here again. So triangles are made of 3 sides, but can any 3 side lengths make a triangle? Is it possible to predict what kind of triangle, obtuse, acute, or right, 3 side lengths will make? Today you will investigate these questions with your team. So let's take a look at this. So remember we talked about this when we did day 1, and we just basically looked at a whole bunch of different triangles. We looked about maybe 13 different triangle lengths and sides, and just said, okay, what type of triangles are they forming, and do they even form a triangle? So if you have that data sheet, you should pull that up, and we're going to start to analyze the data that we collected from 911 day 1. And specifically, we're going to start with question 9-2, and we're going to look at the data from, for the combinations that did not form triangles. So that was the last thing that we looked at, so it's the bottom right, if you have the printed copy of it. And it says, what do you notice about how the 3 side lengths compare to each other, and how are the sets of 3 side lengths that did not form triangles different from the sets that did form triangles? Be as specific as you can. So let's take a look at our data here. So here's our data from that day. So we had 5, 6, and 13 for a small, medium, large, and triangle A. Triangle B was 3, 6, and 13. Triangle C was 3, 5, and 10. And then we had our areas. So take a second to look at this, and if it helps, look at some of the other data too, which should look something like this, and decide why do these side lengths here not make a triangle, and what side lengths will form a triangle. So why don't you pause the video, take a look, see if you can find any patterns. Why did all of these here form triangles, but these here did not? So let me just box that up so we can see it a little bit better. So the blue box around here on the not triangles, why did those not make a triangle, but all of these did? Pause the video and see what you can come up with. Do a little bit of thinking here. Okay, so something that I noticed here, if I look at my acute, obtuse, and right triangles, I looked at if I add up the small and the medium side, they're always going to be larger, or that number is always going to be bigger than the large side. But if I look at it here, 5 plus 6, that's 11. That's smaller than the long length. 3 plus 6, that's 9. That's less than 13. 3 plus 5, that's 8. That's less than 10. So it seems, which then if you really start to think about that, well, that kind of almost feels like a no-duh thing. Because if I have a length here that is 10 long, and then I'm trying to make sides that have to create a triangle, but the sides are only 5 long, so about half of this, and then about 3 long, well, that's not even going to cover that space. You're still going to have these kind of missing 2 here that you'll, and I'm just calling it inches for lack of a better term, it is not even going to cover that length. And so that's why it doesn't form a triangle, because it's not even long enough to basically make up for the entire distance that the long length is. So we might say this like this: the side lengths will not form a triangle if the sum, so adding up all of the small sides, so call it small sides, small and medium, if you want to use that language too, is less than the large side. So if we add up the small and the medium side and it's less than the large side, we know that that will not form a triangle. But then the side lengths will form a triangle if the inverse is true. So if the sum of the small sides is greater than the large side, then it should form a triangle. That's what we're seeing here on all the rest of these up top here, saying that 3, 4 is 7, that is larger than 5. We're seeing that 3 and 4, that's 7, that's larger than 6. We're seeing that 8 and 10, that's 18, that's larger than 12. Let's go on to the next problem here. So we've analyzed how something becomes a triangle. Now let's look at what type of triangle it's going to be, and this is question 9-3. It says, look at the data you collected for acute, obtuse, and right triangles. What patterns do you see between the sum of the areas of the 2 smaller squares and the area of the larger square that forms the triangle? So this one, though, wants us, and this is key here. Notice the question is asking us now to focus on the areas, focusing on the areas, whereas last time I just said the side length. So be sure that you're looking at the area column here. Let's see what our data looks like. So previously we kind of talked about these side lengths, and that stuff is good to go. But the question really wants us to focus on the area. So what do you notice about the areas of obtuse the areas of right and the areas of acute. So take a second, pause the video, do something here. Remember, that's the really important thing here is you doing the thinking. If you're just passively watching, you're not really going to get much out of this, but pause the video, make sure that you look at this and try to figure out what's happening. It'll really help you retain it. Okay, so pattern that I noticed here with this is that I notice on all my acute areas, if I add them up, so 64 plus 100, that is 164. So 164 is bigger than 140, and 36 plus 144 would be 180, and notice that that is bigger than 169. If I go over to the obtuse side, though, and I say 9 plus 16, well, that's going to be equal to 25. That should be less than your 36. And if I do 36 plus 130, that is 136. That is going to be smaller than 169. And we see the same type of thing with our last one, 164. That is smaller than 169. 169. Just barely, but it is smaller. Then if I look at the right, 9 plus 16, well, that's exactly 25. These things are equal. 36 and 64, that's exactly 100. So here are some ideas that I have for what I noticed. On the right triangle, the sum of the two areas is the same, the exact same as the large. If I'm looking at the obtuse, the sum of the two small areas is smaller than the large area. So not talking about the sides. Remember, the sides help us determine if it is a triangle. This is just the area. So if it's an obtuse triangle, the area of the two small sides is less than the total area of the large side. And then for the acute, it's the same type of thing, but the two smaller sides are bigger than the large area. So if it's an acute triangle, my areas of the two small sides should add up to be greater than the area of the large side. If it's an obtuse, the area of the two small sides should add up to be less than the area of the large side. And if it's a right triangle, the area of the two small sides should add up to be exactly the same as the area of the large side. So let's start to use this information to answer questions about triangles without even having to draw them. So let's see what this looks like. Okay, so let's take a look at 9.4 and let's use that information. I've got it summarized down here. If it forms a triangle, the small plus the medium side has to be bigger than the large side. If it's not a triangle, the small plus the medium side should be less than or equal to the large side. Then once we know that it's a triangle, then we can classify it as acute, obtuse, or right. If it's an acute triangle, the small plus the medium area needs to be bigger than the large area. If it's an obtuse triangle, the small plus the medium area needs to be less than the large area. If it's a right triangle, the small plus medium area needs to be equal to the large area. So let's see what we can find out about these triangles here. So I'm first going to decide if it's a triangle or not. This one looks like a triangle because my two small sides, 5 plus 6, is 11. And 11 is greater than 7. So I do know this is a triangle. It does work. Now I just need to decide, is it acute, obtuse, or right? So the areas here that I'm going to get 25, 36, and 49. And 25 plus 36 is definitely going to be greater than 49. So I know that this has to be an acute triangle. Okay, so let's take a look at B. Now here I've got the two small sides of 2, 11, and 15. So first off, I'm going to decide if it's a triangle. Well, 2 plus 11 is 13. That is less than 15. So right here, I can stop right there. This can't be a triangle because the two small sides do not add up to be bigger than the long side. So let's take a look at part C here. We'll do a couple more, then I'll let you do the last few on your own here. So 10 plus 15, that's 25. That's bigger. So we know that this has to be a triangle. And now we're just going to decide what type of triangle it is. Well, 10, let's find the areas here. Okay, I just rewrote this here because I just felt like I was getting too crunched up there. So far we know this is a triangle, but now we're just trying to figure out what the areas are. So the areas here should be 100, it should be 225, and it should be 400. I'm just squaring each of these each of these numbers here. If you don't know some of these off the top of your head, who cares? Just use a calculator. That's what I did. So here, if I add up these two areas, I get 325, and that should be less than 400. So therefore, I know this has to be an obtuse triangle on part C. Let's take a look at the next one. Okay, so part D here, I know that this is going to be a triangle. Just some quick math there tells you that 10 plus 24 is definitely greater than 26, so it's definitely a triangle. And then just have to figure out the areas here. So my areas on this one, I'm going to do 24 squared, and I'm going to do 26 squared, and of course I'm going to do 10 squared. So when I do all those areas, I should come away with 100 for the 10 squared, 24 squared should be 576, and 26 squared should be 676. And so now I just have to decide what happens next. Well, when I add these two up, I get 676. Therefore, these two are equal. So this is a right triangle. This is a right triangle. Let's take a look at our next one here, which is going to be E. And in fact, here's what I'm going to have you do. Pause the video, see what you come up with for letter E and letter F, and I'll show you the solutions here in just a second. All right, so letter E here, if I add these side lengths up, 1 plus 3 is 4. 4 is definitely less than 9, so therefore this is not a triangle. So pretty straightforward on that one. Then when I go to my next one here, I've got 2 squared, which is 4. I've got 10 squared, which is 100. And I've got 11 squared, which is 121. So when I do 4 plus 100, I get, 104 here. Come on. There we go. 104. And 104 is going to be less than or smaller than 121. So if it's smaller than it, then it should be an obtuse triangle. Oh, and I never did my first step. 2 plus 10, that'd be 12. 12 is greater than 11. Therefore, this should be a triangle, but it should be an obtuse triangle. Obtuse triangle. So this is where I can show you that it is important to not just jump straight into the triangle step, because here, if I did this, 1 and 3 squared, that'd be 9, and then this one would be 81, and it would look like this is an obtuse triangle, but this is actually not a triangle on letter E because these sizes don't add up. So it's not actually going to be obtuse, it's just going to be not a triangle. And that's everything that I've got for you today. Feel free to reach out to your teachers if you have any questions. Have a good rest of your day. Bye-bye.